Welcome to the first lecture of week 6 on financial mathematics for actuaries. Lecture number 26 will be focused on arithmetically increasing annuities denoted by IA angle n. Why first of all let us investigate why do we need to study this arithmetically increasing annuities and what are the typical use cases of this arithmetically increasing annuities. So, for that we have to understand that whatever we studied so far was related to level payments. So, we had fixed amount of payments, but in practice, in reality, this may not happen. Most of the payments are not constant. Your salaries increase with your seniority level. The inflation, in case of inflation, the prices rise by a certain percent each year, and in cases of lease the rent increases by some amount every year. That means we are living in a world where the annuities, if we invest, are increasing. Then how to handle them mathematically is going to be the focus of today. So, we will fix our focus right now for arithmetic progression. That means between two consecutive payments there is a constant increase. Okay. So, this is this is something called arithmetic progression. So, in this case, if my first payment is P, the second payment will be P plus Q, third payment will be P plus 2Q. So, if I take a difference of any two consecutive numbers, I will get a constant difference. So, how that reflects into our payment? It reflects as a constant increase by fixed amount in your payments. Okay. So, this is what we are focusing on today, and in the next lecture we will focus on how these decreasing annuities will work, and in the lecture next to that we will focus on geometric annuities where annuities increase by products. So, we will look at as products. So, we will look at them one by one. Today's focus is arithmetic progression. Let us design a roadmap for navigating today. First, we will visualize these arithmetically increasing annuities or annuities increasing in arithmetic progression as staircase function, and then we will actually derive the formula for calculating the present value of this increasing annuities for a period of n. Okay. This so whenever we start our topic, we generally start with a payment of 1 unit and the increase is also 1 unit, and then it's natural to visualize that formula for a general case. So, we will derive that formula in the general perspective, which is the PQ method that we will discuss today. And once we have set up this mathematical framework, we will apply this framework to some special cases, which is salary scales, and let this n tend to infinity, we have the perpetuity case. So, as usual, our reference mapping is very clear. We are looking at Brouwer-Menz section 2.3, Chan and Say section 2.6 for detailed understanding of these topics. Okay. Let us take the first agenda, which is visualizing the staircase. So far, whatever we did, the payments are happening at fixed periods and they are happening at fixed amount. Okay. So, now we want to level this game up. By overcoming this level annuities, we want to see how increasing annuities, like at level 1 you have a payment of 1, at level 2 you have a payment of 2, 3, 4 you have payment of 4, and so on. Okay. So, how is this growth working, or how can we tame this growth is our natural question. So, first of all, to tame this growth, understand that this is a linear growth, because as I mentioned, every time the difference is 1 unit now, if you look at this. Okay. So, this is a linear growth. The growth is happening at a constant rate. Okay. So, how to calculate a present value of this? That is the next question that we need to handle. But by this time you must have mastered this skill, right? So at time point 1 I am having 1. So if I want to get the present value of this, I will multiply by a factor of v. At time point 2 I have a payment of 2. I want to bring it to the present value, I will multiply by v square. 3 I will multiply by v cube. 4 I will multiply by v raised to 4 is the fourth, and fifth I will multiply by v raised to 5, and I will sum over them. That is what we do for finding the present value. So we will do the similar thing for finding the present value and derive the necessary formula. So let us go on to the general formula, where if I have time point n, the payment is due up to time point n, and every time the payment is increasing by 1 unit. At first time point I am having payment of 1, at nth time point I will have a payment of n units. That is very simple. Okay. Now this formula can also be seen as v taken out common into 1 plus 2v plus 3v square and so on up to n times v raised to n minus 1. Okay. But what is happening is I am having a telescopic sum. I am not having a telescopic sum of these formulas, it is just a sum. And how to tame this sum with our known factors, that is what is my goal. So I have some idea about my annuities, and when I am leveling the annuities, I am actually increasing every time the annuity, one new annuity. So how to visualize it? So what I will do is I will do a simple trick, which is I will multiply this v is actually 1 upon 1 plus I, right? So is v. So what I will do, I will multiply with this factor of 1 plus I and get one new sum. Okay. So when I multiply this factor by 1 plus I and subtract the original expression for PV, what I get is very simple. So basically I have multiplied, so this is the thing, minus this PV. So I am actually calculating 1 plus I minus PV. So it is I times PV, and what will I get? Because most of the terms will cancel themselves off. Okay. You can see this. So this is going to happen. 1v will remain 1v and 1 is added here. 2v square 3v square minus 2v square will give me 1v square. And now what is happening is this 1, 2, 3, this increase is being tamed at a level of 1. Okay. And now what is this formula? This is our well known formula. It is a geometric series, sum of a geometric series, and we have already calculated it, that some part is actually annuity due. Okay. So what I proved just now is I times PV is annuity due for n periods minus n v raised to n. Okay. So the present value of this can be written as annuity due minus n v raised to n upon I. So this is our formula for increasing annuity for n periods. What are the key components of this formula that we require? Annuity due present value calculations, which is level 1. N v raised to n is the correction factor that we have introduced at the end of the series, and I is the interest rate. So if I know these three components, or somehow I can calculate these components, I can easily calculate what is the increasing annuity present value. Okay. Now we have to work on some generalized versions, because in reality these payments or differences are not always ones. So what are the payments or differences? So you focus on this. For example, a salary starts with a certain amount, then you get a fixed increase every year, right? So this is the thing that we are looking at, and that is P plus Q, then P plus 2Q. So now if I am working for n periods, its P will always be there, but how many times this will increase? It will increase with n minus 1 times Q. How am I coming to this conclusion? At 1 I got 0 increase, at time point 2 I got 2 minus 1 which is 1 increase, at time point 3 I got 3 minus 1 which is increase of 2, and so on and so forth. So, at nth time period I got this increase. This is very important. Okay. Now, let us visualize this as a layer cake methodology by using this fixed payment of P's as the annuities that we were familiar with for calculating, right. So, this is something like annuity due at the end of first period, or okay. So, this is like first period, second period, third period. So, what will be the formula? This is simply the level part. It is a level annuity, it is leveled up, no increase is happening here. On the top of that you have this increasing part, okay. And now this increasing part you may tend to write this as IA angle N. However, I will show you in some time that this is not correct, okay. This is not IAN. We will show you and we will give you the test cases why it is not correct, okay. So, let us move on and understand that this IAN would have been true if the payment of Q would have come here, that is not coming here. So, this IAN will not be true. We have done this on purpose so that many people will understand what mistake they are doing when they are calculating, okay. So, let us move on. What we are doing is this level payment, I will separate it out. So, I have annuity formula for that. I need to work on those increasing annuities, that is what my worry is. So, I will display the formula and give the rationalization behind that formula. So, here is the general PQ formula. First part is very clear, this is level annuity. Q into IAN is not correct, as I mentioned earlier, it is A angle N minus NV raised to N upon I. Why? Okay. So, let us look at this. This is time point 1, this is time point 2, this is time point 3, and so on and so forth, right. So, when I am applying this formula to annuities, when is the first payment of Q released? It was released at time period 2. And how long it lasted? If you remember, I have written that as P plus Q times N minus 1, right. So, it was N minus 1 times. So, it started at 2 and it ended at N. So, how many payments am I doing with respect to this Q, that increasing annuity? I am making 1, 2, 3, 4 payments, right. If my N is 5, I am making 4 payments. So, what is the crux? I am having n minus 1 payments with these increasing annuities, correct. So, the formula that I should apply will be increasing annuity at, for how many periods? N minus 1 periods, correct. And then I have to take this n minus 1 periods to the present value level. So, if you look at this point where we are doing the payments, it is happening at time point 2, but when we are calculating the value, we are calculating at time point 1, and then we are translating this time point to time point 0. That is where I will multiply this value with V, because this value actually is calculated at time point 1 to 0, correct. So, that is what we are looking at. So, I have this IAN and I will multiply this particular number with V, but this N is N minus 1, okay. So, these are the minor complications that we have, and then now I want to show that this particular calculation actually turns out to be this, okay. So, let us do that one by one. Let me erase some part here. and let me erase some part here. So, now let us look at IA angle n minus 1. What is this? This according to our formulation is A double dot n minus 1 minus n v raised to n upon I. So, this is because I am looking at n minus 1th period, this will be n minus 1. Okay. So, this is the formula. Now, we need to relate this A double dot n minus 1 properly with our annuity, because I want this kind of structure here. So, let us review our relationship which we are familiar with. If I have A angle n, then how will I relate this to A double dot angle n? So, this is the time where the annuity starts at the beginning of the period, correct. So, if the annuity starts at the beginning of the period, this is end of the period. So, this particular thing will accrue an interest of 1 plus I, isn't it? So, this relation will actually help me in deriving this 1 upon 1 plus I is V. So, I will simply take this to the denominator and multiply here with V. So, this is the relation that I will need. Okay. Now, as I mentioned, this particular relation is happening at time point 1 and I have to bring it to time point 0. So, what I need to worry about is V times I A angle n minus 1, right. So, that will be V into this A double dot n minus 1 minus n minus 1 into V raised to n minus 1, okay, upon I. How will I settle this now? So, I will simply push this V, I will use this relationship and I will bring the text over here to here. So, if I have this V into I A of angle n minus 1, that should be equal to, first thing is this V pushed in. So, it got into A angle n minus 1, right. So, it is A angle n minus 1 minus n minus 1 into V raised to n upon I. Denominator is untouched. Now, I will have some more space, so I can do it properly. So, this is A n minus 1 V raised to n minus 1. So, you simply take this A angle n minus 1 plus V raised to n minus n V raised to n upon I. Now, what is this A angle n minus 1 plus V raised to n? It is nothing but A angle n minus n V raised to n upon I. Okay. So, that actually gives me a clear cut hint that this formula should be there. Okay. So, it is basically I A n minus 1 times V. So, that is my increasing part. So, we have derived this formula with little bit of trouble, but we have derived it cleanly. So, now we have this formula which essentially says that when I am using PQ formula, I will never use annuity due, I will use annuity immediate. This is very important for solving problems, because generally people confuse in these kind of problems. So, just remember this. Okay. So, let us take one example and try to use whatever knowledge we have. So, I have a salary of 50,000, which is the year 1 end salary. Then after that, every year salary increases by 2,000. The salary term is 20 years and the interest rate is 5%. You are asked to calculate the present value. So one thing is very clear, you have to calculate the level annuity, and the second one is you have to calculate that increasing part, and increasing part, because it is 2000 which is not equal to that 50,000. So you cannot use the annuity formula, increasing annuity formula. You have to use the PQ formula that we have discussed just now. Okay. So let us identify the PQ parameters of the P is 50,000, Q is 2000. Apart from that, I need period, N is 20 years, I is 5%. So I am ready to use the formula. What is the formula? Formula is P times A angle N into Q times A angle N minus N V raised to N upon I. Okay. So I will simply push all the values into that and get the answer. First we will finish off with the level part, which is A20 at 5%. So that can be easily computed as 12.4622. You already know what is the formula, 1 minus V raised to N upon I, that is the formula that will give you this number. Okay, and multiply it with 50,000, you get this number. There is no confusion here. The new product that we have is increasing part. So there I do not have to use annuity due, I have to use annuity immediate. So A20 only is required. NV raised to N you can easily calculate, it becomes 7.538, and then it is just a matter of algebra. You substitute them and get the answer and multiply the answer that you got with 2000 to get the number of this level increasing annuity payments. Okay, and then you add both of them and get the answer. Remember to use memory functions to avoid the decimal errors. Okay, so we have done this. Now so in order to avoid decimal errors, you have to remember this memory function, how to use the memory function. For that I am giving the workflow where you will calculate AN, you will store it into your memory, then you calculate NV raised to N, then you, for computing this AN minus NV raised to N upon I, you use the recall function, and minus, if you want you can store this in store 2 also, NV raised to N you can store it in store 2, recall 1 minus recall 2, and then divide by I, then multiply by Q, and then finally add P into RCL, which is recall of the stored value of AN, that is 1, right. So if you follow this you will have lesser decimal errors. Okay. Now we have understood how to calculate the present value. The next question can be how to calculate the future value, or what are the implications in future. So for that let us look at that formula. One basic principle that you should stick to is, for calculating future you calculate the present value, push it the number of time periods forward with 1 plus I. So that is what we will do. So if I have increasing annuity at N for N periods, then if I want to calculate present future value, then I will push it by N time periods by multiplying with 1 plus I raised to N. Okay. So if you do that you can push this into the formula, and then you will see that you get ISN expression to be S double dot N, which is future value of annuity due minus N upon I. But this is not actually required. If you stick with your original calculations, present value into 1 plus I raised to N, you will be more happy. Okay. Now the next question is, we have calculated present value, future value. What if the payments of these annuities, increasing payments, last forever? What will be the value, right? So that is the question that we will ask, and that is called increasing perpetuity. So our basic goal is natural. So this is what we will look at, that n tends to infinity. So I a infinity will be limit as n tending to infinity of our increasing annuity. Hmm. So, what are the factors that are dependent on n? That is what we need to identify first. I is independent of n. So, this is safe. A angle n, A double dot angle n is dependent on n, and n v raised to n. Now, you look at the factor of n v raised to n. Here n is increasing linearly every n, but v raised to n has exponential thing. So, together v raised to n will dominate the increase of n, and v raised to n is a decreasing factor, right. So, n v raised to n will together converge to 0, that is one important fact. Then this annuity due we have already handled. What was A double dot n tending to when n was tending to infinity? We already know the answer, right. So, we had something like 1 minus v raised to n upon d, and then we took the limit as n tending to infinity of that. So, this should naturally converge to 1 by d, right. We already know that, okay. So, that should resolve the problem. That means I know how both factors A double dot n and n v raised to n are behaving. One will converge to 1 by d, another one will converge to 0. So, what should be the final answer? So, A infinity or the present value will be 1 by d minus 0 upon I. So, it is 1 by d upon I. But what is d? D is I upon 1 plus I. Substitute that and get the answer to be 1 by I plus 1 by I squared. So, that is the basic answer. So, what is the interpretation here? It basically relates very well, because this 1 by I we have seen as a perpetuity, right, for level payment of 1. So, this is the fund that you require for level payment of 1. And what is 1 by I square? Again, you have growth every 1 year, right. So, for that you need a fund of 1 by I squared. Okay. So, this is the idea behind this particular formulation. So, this is how we will understand increasing perpetuity. Now, it is time for you to to it's time for you to use whatever we have learned today. So, here is the problem where you will actually implement the strategies that we learned. So, it is a scholarship problem. Year 1 you are getting $1,000, year 2 you are getting $2,000. The scholarship increases up to 10 years to $10,000, and year 11 onwards this will be leveled at $10,000 forever. So, if the interest rate is 6%, can you calculate the present value? Just try your hand on the other side. I will solve the problem for you. Pause this video and try for yourself. Welcome back. So, first we will handle, if you look at the problem, there are two kinds of issues. First part is year 1 to year 10 there is an increasing annuity, and year 11 onwards there is a leveled perpetuity. So, we will handle these two parts separately, and this leveled perpetuity will start from 11th year onwards. So, it is called deferred perpetuity. So, we will solve them one by one. Let us take the first part, which is increasing annuity, years 1 to 10. What is P? P is 1000, and the difference is also 1000. There are 10 time periods. So, I will simply deploy the increasing annuity formulation that we have, and from the interest rate of 6%, we can easily see that increasing annuity comes out to be 36.96, which we will multiply to, because here P is equal to Q, we will multiply it to uh, P or Q, whatever you say, 1000 into 36.96, that gives me 36,960. And after that I have to consider the deferred perpetuity, which starts at time point 11. So, I need to calculate the value of this perpetuity at time point 10. Okay. So, that is the important thing, and that value of level perpetuity 10,000 is will be 1 by I, right. So, 1 by I multiplied by 10,000, which is V10, 10,000 divided by 0.06, which gives me 1,66,667, and this value I need to bring backwards by 10 years. So, I will multiply by V raised to 10, which is 1 upon 1.06 raised to 10, which is 1.06 raised to minus 10, and therefore, the value is 93,066. What is the final answer? Sum of these two values. So, just sum them, and that is what your final answer is. That is what will be your present value, right. So, we have covered a lot. We have seen how standard annuities work. Okay. So, this is standard increasing annuity, where the increase is by 1 unit per year, and in that case our formula becomes annuity due for the time periods minus the number of time periods V raised to number of time periods upon I. However, if I want to use the first starting point as different value and the increase as different value, we need to rely on this PQ method. In this particular method, you do not rely on annuity due, you work with annuity immediate, and the formula becomes P into A annuity immediate for n periods, Q into A annuity immediate minus NV raised to n upon I. And if I want to consider perpetuity for 1 unit periods, it is for 1 unit of money, 1 by I plus 1 by I square. Okay. Calculator liberally use memory keys to avoid decimal errors. In the next class, we will discuss the concept of decreasing annuities, and we will see how it is related to increasing annuities, so that you can save some time on computational exercises. See you in the next class. Thank you.